Hey everyone, my name is Jim Fister. I'm an independent contractor for the Storage Networking Industry Association, and I also run my own company, The Decision Place. And with me is Steve Swanson. Steve, say hi.
Hello, everyone. I'm Steve Swanson. I'm a professor at the University of California in San Diego. And Jim and I are the co-organizers of the PIRL Conference.
So as we did in week one, we started off with a panel discussion. So we had 4 pre-recorded talks this time. The presenters from those 4 presentations were assembled in a panel. So Steve, why don't we actually talk about the panel first? So what did you think about the panel? What struck you the most in terms of what we had in there?
Sure. I thought I liked all the talks pretty well. And the full-length videos are available on the PIRL website, so you can watch the whole thing. I believe the first talk was Dan Williams from Intel talking about the current kind of recent updates on Linux kernel support for persistent memory. And that's always, he's an entertaining speaker and tells some good stories. And it's also good to get a little bit of a view of where PMEM development is going and kind of what challenges the kernel folks are concerned about and tracking. That gives a good picture of where that support's going to end up in the future. I don't think there were any huge surprises in Dan's talk, but they're kind of slowly adding new features that are going to make persistent memory more and more useful and more flexible on Linux machine.
Yeah, and what I liked about Dan's talk is it was a continuation of something that we did at PIRL 2019 as well. So you can actually look at both those videos. We've got the live presentation, which was about an hour long, and then his pre-recorded one was, I think, about 20 or 25 minutes. And then we had the Intel team from Poland was talking about container support in C++ for persistent memory. I thought that was pretty interesting, and I really liked the library support. Did anything strike you in that?
Yeah, I mean, this was another presentation that was a little bit of a follow-on to something that appeared at PIRL last year. And this is kind of, they're both of the presenters are members of the core PMDK development team. And PMDK has been interesting to watch it evolve over time. And now they're really getting into building data structures that are going to be useful for programmers in lots of different situations. So you mentioned the container support. And to hear them go talk about the challenges of building high performance persistent containers, I think is useful lessons for people that want to build their own customized data structures, which at least in my experience, we always end up with a custom data structure, even though we may start off with something like the STL. So seeing how those guys are kind of leading the charge in that direction was great.
And then we also had a research presentation, and it was really interesting about the power fail testing of persistent memory, and that was Harris Volos, and I believe he and Terrence Kelly had combined on it, but Harris supported us with the presentation and the panel. That was really interesting. He spent a lot of time actually talking about the physical setup that he had put together to do the testing, and then he talked about test results. I thought that was a pretty interesting talk, and really shows kind of the depth of discussion that you can have around persistent memory. What did you think?
I mean, I love hardware and I love breadboards, and so the little rig that Terrence put together, I think, was pretty cool from the perspective of doing good testing, which is a huge challenge. I'm hoping that that will lead someone to develop a methodology for doing testing on larger scale servers. There's focuses on kind of Raspberry Pi class devices that don't have the sort of full-blown persistent memory hardware that we can find on Intel machines. But you should be able to build a similar device. It'll be a little bit more expensive, but that kind of testing, I think, is critical. There's no simple regression for determining that you recover properly from a messy shutdown.
And then, if I recall, the last panelist was Sasha Fedorova, and she actually she's a professor at what was the school again? Do you remember?
I believe she's at Simon Fraser, but I'm not sure. So
it's Canadian on the West Coast. We both remember that. And then, but Sasha also is a contractor for Mongo, and so she was actually doing a database retrospective where she was actually looking at the performance on persistent memory in comparison to the performance on a solid state disk. And I thought it was interesting. One, I thought it was a very, very thorough analysis of the work that she was doing. But she also, had a few surprising results where the solid state disk sometimes had some advantages over persistent memory, and I think a lot of it was really the disk caching scheme that persistent memory actually supplies. But it was a really nice, thorough presentation. I thought she did a very good job, and I'd really like to see some follow up with some bigger memory system or larger sized memory systems. What do you think?
Yeah, I thought that was an interesting presentation. I just checked. She's at UBC.
There we go. Sorry, Sasha.
Um, yeah, I thought, it's great to see, a real piece of software running on top of persistent memory. I thought that, they could have gone farther in terms of integrating persistent memory into MongoDB to see what it could do. If you imagine rebuilding MongoDB kind of from the ground up, or maybe even making more aggressive changes to how it used storage. But it's definitely a good first cut in looking at how to port a system like MongoDB to a new storage technology.
Yeah. Well, I'm going to tell everyone out there, stay tuned because I've actually been talking with Sasha a little bit, and we might have some opportunity to have her present again on some further work that she's going to do. So maybe we will get a little more work out of that project a bit. So that was the panel discussion, and then we also had two keynotes, and the first one was Samir Razada from Verizon. So it's the Yahoo team that's at Verizon now, and he was coming at persistent memory from an information technology perspective and how they're using it. What struck you the most out of that presentation?
Yeah, I thought it was, they've done some really kind of innovative things in terms of internally trying to brainstorm about how to use persistent memory. He talked about some of the internal hackathons they've done and what's come out of that. So I encourage people to sort of take a look and hear what their experiences are. But I enjoyed it. I enjoyed it quite a bit. I've talked to them some since then, and they're doing lots of cool stuff at Verizon, which for me it's a surprising place. I guess they came from Yahoo, but it's cool to see a new player, a new company in the arena.
Yeah, definitely agree on that. It's great to see a new player, and I think for those of you on the IT side, I agree with Steve. I think it was really neat to see some of the work that they were doing just to test persistent memory, and it's a really good example of what you can do to figure out how it's best going to fit in your environment. And then, if I recall, our final presentation was from William Wang of ARM. And he was actually talking about some of the theoretical implementations that the ARM processor might use for persistent memory. I thought that was a really neat presentation, and it actually, really wowed the crowd as well, if I remember. I heard a lot of good feedback after the session, and I think it's really nice to see that, a lot of people think that persistent memory is just, one thing, it's an Intel thing, but this is an industry standard technology. It's available in a variety of places. We have current Intel and AMD platforms that support it, and seeing ARM come in to try and figure out how they're going to support it, I thought was very encouraging. What was your take?
Yeah, I thought it was great to see how the other ISA is going to handle this. I personally, I'm a little disappointed that it's not more different than what Intel is doing, because I think there's some drawbacks to the way that things are heading in terms of the memory model and so forth. But hearing about what ARM is doing, and there are some details that are different, and that's interesting. And it'll really kind of open up the kind of space of what is possible and what we're going to see in systems. Another thing that I think is really important is that ARM is going to be the ISA that's going to take persistent memory into the embedded space.
Absolutely.
If we think about really small devices, which is not some place where persistent memory has been, at least not in a large way, but I think it will eventually end up there, and it's going to be almost certainly on ARM hardware. And so getting a glimpse of what that'll look like, I think is really valuable.
That's a good point, and from an architectural standpoint, you can really think of a complete change of embedded devices. A lot of them look like small systems right now, or some variant of a cell phone or some variant of a tablet or a PC. But now all of a sudden you can start talking about a system with a flat memory space that's fairly large, but also at the same time draws almost no power from an idle standpoint. I think that is a really exciting thing to see for persistent memory moving into that space. I would agree.
And there'll be even smaller devices, right? Things that maybe don't have an operating system, run in deeply embedded contexts, where energy is important, but you need some storage to do sensing or something. And so persistent memory, I think, that's an underexplored area.
Well, we have one more week of PIRL coming up. I'm very excited for that. And for those of you who are viewing this video, you can go to PIRL, PIRL.nvsl.io, and we have the whole program there, and video will be available starting in November for you to be able to view. So by the time you see this video, those videos will be up. So that's PIRL.nvsl.io. Steve, thanks for your time this week, and we look forward to seeing you all next week.
No problem. I'll see you at week 3 of PIRL.